Now we are on the next topic, which is the inverse questions. So previously we have this kind of questions. So if I give you that this 0.45, then you have to figure out what is that value using the table or whatever. I can ask you this kind of question instead. So if I want to know if I want the area to be 0.x, whatever it means, I will explain that in a moment. Can you find that value such that the area is 0.x? Right. Instead of giving a point and find the area, now I'm giving you the area and ask you to find the point. So this kind of question corresponds to this kind of image. So you have that curve, right? You don't know what that point is, and that's the question. But what we know is that this area is 0.x. If the area is 0.x, can you find that point? Okay. So that you can answer that question using calculus, right? And of course using the tables. But first let's see if we can do better than that. Okay, so the question was 0.x, right? So I put it in 1. I got the area to be 0.x for 1. That means the point 1 here is too far to the right. That's too high. Right, I want the area to be 0.x, but that gives me 0.x for. So the next thing is you might want to try to change the value, decrease that a little bit. Let's say that's 0.9. Oh, now it's getting closer, right? Because x moved to the left, the area is decreasing, right? From 0.x4 to 0.x1 now. You get smaller one, but that's not good enough. You want exactly 0.x, so just kind of change that. Oh, that's too much. I know that's too small. Okay, so we have to move back to the right, maybe 0.85. Oh yeah, that looks just right. Maybe that's good enough for for whatever computation you are doing. But maybe we want that to be more precise. Oh, 0.85 is a little bit too high, so maybe we want to use a smaller number. 0.49. That's still slightly too high. 0.48. Yeah, close. 0.47. Oh, better. Maybe 0.45. Yeah, even better. Okay, so that's the process here. The idea here is trying to. Oh, that's too small. Yeah, that seems like the right place to stop, about 0.842 or something. Right? If all we know is the probability on the left, or if all we know is the t is a z table, then we have to use that method. So let's go back to the notorious z table. So we have the z table here. So the question is, if I ask you to find let's say remove what we had before. If I want you to find the value such that this probability is about 0.3. Let's say 0.3. So now you look at this table and see what values are closest to 0.3. This is what we just did. Looks like that thing. If you look on the screen, you need glasses or magnifying glasses. But yeah, that looks like that, and that. Okay. So that means we know it's between what, minus 0.5. Oh, what's on the top? 0.52 and 0.53. So 0.52 and 0.53. So we know it's between one of these two values. And the value that we want is between that. Maybe you want to use the small one or the large one, your choice. But this is what we did here, and we put in the values and see if we get closer and closer to the value we want. But this app is, the thing is, it's just intelligent, so we can actually just put that value there. And if you click on there we go. It's 0.84162. So if you have a good tool, it can solve problems in both ways. Given x, we can find the probability, and given the probability or given the area, it can give you the point instead. So we have x has to be something close to that value, so that the area is point x. And so that's how you use that. So let's see some example questions. Yes, I call that inverse problem, but it's not actually inverse. So right here, find z such that the area between that two and that is 0.25. Then of course you have to both compute or use some tools. If you go back to this, if you use this tool, you can see that there is no option to compute the probability between 0 and that value. So you have to improvise, and improvising means, but you want that, right? For the first question, you want just this area to be 0.25. Okay, but the web that we use doesn't have that too. But what it does, what it could compute is the whole area, all the way to the left. So if that is 0.5, and we know that the left part, the left half is 0.5, then we can instead ask the question of ask the question of finding the value of z1 or any value such that this probability is 0.75. Now we can use that thing we had. So if you want it to be 0.75, put that in, and there we go. We have got about 0.674. So in the first question, you say that no, it's about 0.674. Yes, that's the question. That's it. So I would say like by inspection or something, you get that value. And if it's this far in the homework or whatever, then you could, I would expect you to use the tool. But if you write it on the paper, or if you use any app, then you should show the whole thing. You should show that, oh, by this calculator, if I put the value 7.75, if this is 0.75, that is what we got on the right, and that justifies. That's the way you show your work. If by use a screen cap here. So that's about 0.67. The second one is point. You want to find the point where the left part is 0.2? Sure, of course. Go then. You want that to be 0.2, and there it is, 0.8162, which is the value that we got before, because that is equal to 1 minus that prop to the left instead. Right, the area to the right is 1 minus the area to the left. And if this is 0.2, then that is 0.8. That's why we got the same value as before. So here's the second one is about 0.8162. Third one is it's just the usual one, less than or equal to 3. That actually is given there already. So just put that in as a 3, and then you get minus 0.5244. Remember that since 0.3 is less than half, then the answer, the value of x has to be to the left of 0 as well. Because if it's at 0 sharp, then the area would be 0.5. That would be too much. So we have to keep decreasing, keep moving to the left until we hit 0.3, until we get small value. So C of 3 is about, what was that, 0.5? Oh, it's gone. 0.3, yeah, 0.5244, I think actually. So yeah, that's if you are asked this type of question, the only way to do is to use an app. And you might ask that why do we have to care about the area instead? Because this is actually the main application of this type of problem. Right? This corresponds to like all types of questions. So the first question, the intuitive question is about asking about the percentile. Right? If you are, let's say if you are taking an exam, and the score is, you know, the usual 100 score max. If you are 80%, if you are the 80 percentile, 80 percentile, right? Then what would be your score? Right? Because the exam, let's just say like the score of the exam is normally distributed. It follows a normal distribution, right? Then it's not gonna be, you know, it's not gonna be the flat from 0 to 100. That would be possible in some scenarios, but for the exam, you know, most of the people are gonna, you know, fall into the mean. So this kind of exam is gonna look like that. If you want to be the 80 percentile, like, or at least like 4/5, like that means you want to be better than 4 out of 5 of all the people on Earth, right? It's not gonna be that at exactly 80, because if the point is 80, right, then it means that the area, the point is 80, but the area to the right of that point is not 0.8. Right? If it's 80 and 0.8, then that means you are looking at the uniform distribution. And because maybe if there are like 1,000 people, then you say like 10 of them got 0, 10 of them got 1, 10 of them got 2, 10 of them got 3, and so on until, you know, 10 of the people got 99, 10 of the people got 100. Right? That would be a funny world we live in. Like, that's not how the score are distributed. The score distributed like roughly this way. So the 80 percentile is not, you know, it's not 80 points. You actually have to know, you know, you have to know mu and you have to know sigma and the stuff to determine. But here, for the 80 percentile, it corresponds roughly to this, you know, 0.8. Right, and so it says it's about like 0.84, which you still have to compute that out, and have to adjust the mean, the mu and the sigma to the right numbers. But the idea about the percentile, you know, and the value, they are two different things. The percentile is represented by the value, the probability, but the value itself is represented by, you know, what is the range. So you may want to, you know just know what is your percentile. You want to know sometimes about the let's say the top on the bottom. Let's just say the bottom 5%. What it means to be the bottom 5%? It means, suppose that, you know, all the stuff are nicely distributed in this pattern. Let's say you produce, you are a factory and you produce, you know, some stuff, and stuff are, you know, you get good and bad stuff because you use machines, and machines, even though they are precise enough, they are not gonna produce the same object over and over. Let's say you produce drinks, and some drinks gonna contain exactly the amount indicated on the side, say 300 milliliters. But, you know, by some imperfection, some gonna be slightly more, some gonna contain slightly less amount of drinks. Right. So you have to compute all these things, and let's say you want to, you know, maybe discard the 1% that are not met by the standard of your factory. So you have the number, right? You want to discard 1%, but then you want to ask, wait, how do we know what is the 1% cut off? If the average is 300 and some is heavier, some is lighter, then how do we know that, you know, what value would correspond to 1%? It is, you know, to 95. Do I want to discard all the drinks that is lighter than, that has smaller volume than 295 milliliters? Would it be too much or too small? that would be the question I have to ask. Like, so from the percents from the left hand side, you would be interested in, you know, determining exactly what is the left hand side, or what is inside the parentheses, what is the value, what is the cutoff. And also another question you might ask is you might want to look at the center. So if you know that part is the average, you want to know if you want to sum. Let's say you have this kind of like score, and you are looking at, you know, let's say 60% around the average. 60% around the average. Okay. Because again, maybe you are talking about drinks and you want to consider all the average. Like, you only ship the things that fall into the average. The things that are too extreme, like too high or too low, too heavy or too light, you can, you know, discard them. Or maybe if it's people, you can kill them off. You can ask about, you know, 60% around the average. The image we have in your mind would be that it has like left and right cut off. Maybe that's, you know, that's one. We have to change the scale anyway. But if you have these questions, and that's again the question about the right hand side, and you want to know the cutoff, you want to know what values should I look into. So in this case, like 60% is 0.6, right? But since you want the area between these 2 points to be 0.6, then that means you want each of these to be 0.3, half and half. And then from that point you can figure it out. And actually this is the type of frequently asked questions, so it's actually like half. I think that you can just get it. So the probability that the value of x is, you know, this area is 0.6. If you want that area to be 0.6, the area around the center to be 0.6, then the cutoff, the value of x is to be 0.84162. Again, that looks familiar, right? But that means this is the right part is 0.84, the left part is minus 0.84. So the area in between is about 0.6. And we're gonna go into this kind of questions in details next. Oh, I have to hit that. Alright, so that's the third part. So let's see you again in the next part.